The first problem is if you fall into a black hole, what will be seen? Question 2. Why is the speed of light the ultimate speed limit of the universe? The third question is whether time travel is possible. The fourth question is if aliens exist, why we never saw them. The fifth question is whether the universe has boundaries. These 5 questions, if you can't answer, then you are here today, because after reading it, you will find out. The final answer points to a truth that you would never have thought of. Let's talk about the first question. What will you see if you fall into a black hole? Many people's first reaction is, there is not even light to escape there. It must be pitch black. But the reality is far more bizarre than you think. First of all, we have to figure it out. You are a bystander watching others fall into a black hole, or did you fall in it yourself? Because of these 2 situations, seeing something completely different, and they are all outrageous. Let's say you're standing at a distance. Watch your friend Lao Wang fall into a black hole. You will see that Lao Wang will drift slower and slower. Finally, it is frozen at the edge of the black hole. Never really fall in. From your perspective, Lao Wang will be stuck there forever, turned into a darker and darker red shadow. Finally disappeared from your field of vision. But he didn't really fall into it. It's just that you can't see him anymore. This is because the spacetime near the black hole is distorted too much. The closer you get to the black hole, the slower time passes. From the outside, Lao Wang's time almost stopped, and photons emanated from him. To climb out of the black hole, the strong gravitational wavelengths are elongated. The color changes from white to red. Finally, it becomes infrared. The human eye cannot see. This is the famous gravitational redshift. But what if you are Lao Wang himself? The experience is completely different. From your point of view, you will be at normal speed. Falling into a black hole doesn't feel like slow motion, but you'll see the universe out there speeding up. It's like someone hit the fast forward button. You may see the birth and death of stars are rapidly unfolding before our eyes. See the future of the entire universe flash by in seconds. This is because time outside is speeding up relative to you. What's even weirder is that when you really get close to the world of events in black holes, when that layer of irreversible boundaries, you will see something very strange. First, you will notice that the space around you begins to distort. The stars that were originally behind you may appear in front of you because black holes bend light. You may even see the back of your head because of the light that comes from the back of your head. The black hole is bent in front of your eyes. But it's not these visual spectacles that are the scariest. It is a phenomenon called pastization. The name sounds pretty cute, right? But in fact, it's one of the worst deaths you'll ever encounter in your life, because the gravitational gradient of a black hole is too large. The gravitational force that your feet and your head are subjected to is huge. If you put your feet first, the gravitational pull on your feet, it will be much bigger than your head. The result is that you will be stretched longer and longer, like a spaghetti, and not just longitudinal stretching. Your body is also compressed laterally. Imagine this. You become a few kilometers long, but only a few centimeters thick human meat noodles. Every atom is torn apart. This process has an academic name. It's called tidal tearing. But here's an interesting detail. If the black hole is particularly large, for example, that supermassive black hole, the kind that is billions of times the mass of the sun, then when you cross the world of events, it may not be shredded immediately, because the bigger the black hole, its world of events, the larger the radius. The tidal force in the event world is smaller. You may be able to walk through the world of events in its entirety, then float inside for a while. Will be slowly torn to pieces. But anyway, The ending is all the same. Nothing can come out of a black hole, or at least that's what we think. Until Hawking jumped out and said something wrong. Black holes evaporate. This leads to deeper questions. But before saying this, we have to solve the second problem first. Why is the speed of light the ultimate speed limit of the universe? Many people think the speed limit of light is just a traffic rule, just like the highway speed limit of 120. It is arbitrarily determined by some kind of cosmic law. But in fact, light speed limit, it grows from the essential structure of time and space. Einstein in 1905, when the special theory of relativity was proposed, I found one thing. The speed of light is the same in all frames of reference. This statement sounds simple, but think about it. You will find it very weird. You think if you stand on the ground, see a beam of light flying at a speed of 300,000 kilometers per second. Then you jump on one, a spacecraft flying at a speed of 100,000 kilometers per second. Go chase that beam of light. According to common sense, you should see the speed of light becomes 200,000 kilometers per second. Right, but it's not like that. You will still measure 300,000 kilometers per second. If you accelerate the spacecraft to 290,000 kilometers per second, infinitely close to the speed of light, guess what the speed of light is? Or 300,000 kilometers per second. It's like no matter how you run, the light is always at the same distance in front of you. Here's how. The answer is terrifying. Time and space are automatically adjusted. When you accelerate, your time will slow down. Your space will shrink. Just so that the speed of light seems constant to you. This is not light. What special abilities do you have? It is the property of space-time itself. So why is it 300,000 kilometers per second? What about this number? In fact, the number itself is not important. The important thing is that it is a limited speed. If you put the value of the speed of light, bring it into the formula of relativity, you will find one thing. Any object with mass wants to accelerate to the speed of light. Infinite energy is required. This is not to say that our technology is not advanced enough. It is mathematically impossible, because the closer you get to the speed of light, your quality will get bigger and bigger. Acceleration is becoming more and more difficult. It's like climbing a mountain. The higher you climb, the steeper it becomes. When you approach the speed of light, the mountain has turned into a vertical wall, and this wall is infinitely high. But why can photons reach the speed of light? Because photons have no rest mass. It is born at the speed of light. No need to speed up the process. It cannot be faster than the speed of light. It cannot be slower than the speed of light. Because the speed of light is how it exists. This leads to a deeper question. The speed of light is not actually the speed of light. It is the speed at which causality spreads, or the fastest speed of information transmission. The universe is not limiting light. It is limiting all causal relationships. If causality can propagate faster than the speed of light, then the causal law of the entire universe is messed up. You may see it in some frames of reference. The result precedes the cause. Time loses its meaning. When it comes to time losing its meaning, this naturally leads to the third question. Time travel is impossible. There are two types of time travel. Go to the future and go to the past. Going into the future is actually very simple. You are moving into the future now. Every second is a second into the future. But if you want to fast forward, there is a way to do that. According to the theory of relativity, you just need to run fast or stay in a place with a strong gravity. Your time will slow down relative to the outside world. You're fast forwarding to the future. This is not science fiction. This is reality. GPS satellites must consider the relativistic effect. Because they move very fast in space, gravity is also weaker than on the ground. So their time is different from the ground. If this error is not corrected, GPS positioning can deviate by several kilometers per day. There is a classic thought experiment called the twin paradox. Suppose there is a pair of twin brothers. Travel to space in a spaceship that is close to the speed of light. The younger brother stayed on Earth. When my brother comes back, he may have only passed 5 years, but 50 years have passed on Earth. The younger brother has gray hair, and my brother is still young. This is not a paradox. This is the real effect of the relativity prophecy, and it has been confirmed by countless experiments. So traveling to the future is simple. Find the edge of the black hole and stay for a while, or take a walk in a spaceship that is close to the speed of light. When I came back, the Earth is already the future, but travel back in time. This is troublesome. Theoretically, it is not entirely impossible to travel back in time. Einstein's general theory of relativity allows for some strange spacetime structures. For example, a closed time curve. That is, time can go around once, back to your starting point. Wormholes are one possible solution. He opens a shortcut in time and space. Connect to different spacetime points. If you can make a wormhole, then accelerate one end of the wormhole to close to the speed of light. Coming back to that port will slow down. The two ends of the wormhole will be connected at different points in time. You go in from the younger end, come out of the old end. It goes back to the past. Sounds perfect. But here comes the problem. First of all, the wormhole itself is extremely unstable. It requires something called negative energy to maintain. And the negative energy is on a macro scale. It is almost impossible to exist. Secondly, even if you actually create a time machine, you will also face various paradoxes. The most famous is the grandfather paradox. Let's say you go back in time and kill your grandfather. Then you won't be born. You are not born. You can't go back in time and kill your grandfather. Then your grandfather will not be killed. You will be born. Then you can go back and kill your grandfather again. This cycle cannot be solved at all. Physicists have worked hard to solve this problem. I saw the various ways. Some say the timeline will diverge. You killed your grandfather in a parallel universe. It doesn't affect your timeline. Some say the universe will correct itself. Every time you want to kill your grandfather, will be inexplicably defeated. Others say, in fact, you can't go back at all. A point in time before your own existence, because that would violate the law of cause and effect. But my personal favorite point of view is, time travel is not impossible, but the price he needs from you is too great. Think about creating a wormhole. The energy you need. It may be equivalent to the mass of an entire star. You need to maintain the negative energy that this wormhole needs. It may take you to take half the galaxy of matter, convert it into energy. It's not a technical issue. This is an economic problem. It's as if you could theoretically use your hands, atom by atom moves, to build a mansion. But in reality, no one would do that. And even if you really have so much energy, you also need to consider one thing. Once your time machine is built, it will attract from the future all time travelers, the entire future history. All those who want to go back in time will all huddle in line next to your time machine. This time machine, it will become a transportation hub in time and space. The relationship will be in a mess there. The universe may be confused because of this cause and effect. And self-correction. The most direct way is to let this time machine destroy the moment he was built. So the result we see is, time travel could theoretically exist, but in fact, The universe seems to have a set of self-protection mechanisms, prevent the law of cause and effect from being broken. Physicist Hawking. This is called the continuous protection conjecture. The gist is that the laws of physics protect history. Don't let it be changed. Speaking of protection, this naturally leads to the fourth question. If aliens exist, why we never saw them? This question has a special name. It's called the Fermi paradox. Italian physicist Fermi, at a lunch in 1950, casually asked where they were. Behind this simple question, there is a huge contradiction. You think the Milky Way has over 200 billion stars. There are 2 trillion galaxies in the observable universe. Even if the probability of life appearing is extremely low, for example, 100,000, there should be countless civilizations that exist, and the universe has existed for 13.8 billion years. Even if civilization is slow, as long as it evolved millions of years before us, their technology should far surpass ours. It is calculated at 10% of the speed of light. A civilization can completely be done in a few million years, colonize the entire galaxy, but we didn't see anything. This is the heart of the Fermi paradox. The universe should be full of aliens, but we didn't see any of them. Scientists have proposed dozens of possible explanations. Some are optimistic, some are pessimistic. There are also some creepiness. Optimistic explanations include that they do exist, but we haven't found it yet. Maybe they are too far away from us. The light hasn't come yet. Maybe we don't understand how they communicate at all. Just like you use your phone to receive a telegram signal. Probably they don't want to expose themselves, hide from us. These explanations are possible, but there is no way to explain it. Why in the entire observable universe, not a single signal was received? The pessimistic explanation is disturbing. The most famous one is called the big filter theory. This theory says, evolved from simple life to advanced civilization. There is one or several extremely difficult levels in the middle. The pass rate of this level is extremely low, so low that almost no civilization can pass through. The problem is, we don't know where this big filter is. If the big filter is behind us, for example, from inorganic to organic, or from unicellular to multicellular, then we're in luck. We have gone through the hardest part. But if the big filter is ahead of us, for example, any civilization develops to a certain extent, will self-destruct, then we're in trouble. We may be heading towards one, a trap from which all civilizations have not escaped. There is an even more frightening explanation. It's called the dark forest theory. This theory assumes that the universe is a dangerous place. Exposing yourself is equivalent to seeking death. Once any civilization is discovered, may be wiped out by higher civilizations, because you don't know that the other person is friendly, still hostile. And once the bet is wrong, the price is extermination. So the wisest strategy is to remain silent. Hide yourself. At the same time, vigilantly monitor the surroundings. If other civilizations are found, the safest thing to do is to strike first. Under this framework, the answer to Fermi's paradox is simple. They are all there, but they all shut up. And we humans have been doing this for decades. Been shouting at the universe. Broadcast our location. If the dark forest theory is correct, we probably already on the list of strikes of a certain civilization. But I personally think one of the most interesting explanations is the zoo hypothesis. This hypothesis believes aliens do know that we exist, but they deliberately do not touch us. Just like we observe animals in a zoo, they may have some kind of interstellar convention. Do not interfere with the development of low-level civilizations. We are to them, just like ants do to us. You see an ant while walking down the road. Will you stop to talk to it? No, you won't even notice it. Or even further. Possible. We are simply living in an alien simulation. They are watching us, record our actions, study how intelligent life develops. The idea sounds like science fiction, but it's actually a serious philosophical question. If a high-level civilization, capable of creating realistic simulated universes, then they might create many to experiment with. That's how it works. The probability that you live in the real universe. On the contrary, the probability of living in a simulated universe is smaller. Whichever explanation is correct. The Fermi paradox points to a fact. The universe is more lonely than we think, or more dangerous, or even weirder. And the answer to this paradox, it may be related to the boundary problem of the universe. This leads to the fifth question. Is there a boundary in the universe? Many people's first reaction is, of course there are boundaries. Isn't the place where the Big Bang begins the boundary? But in fact, this is one of the biggest misconceptions about the universe. First, the Big Bang. Not an explosion that happened somewhere. It is the expansion of the space itself. This is not a bomb exploding in space, but the space itself is expanding. So there is no explosion center. Each point is the center. Each point is moving away from the others. You can imagine a balloon's surface. There are many dots drawn on it. When you blow up the balloon, each point is moving away from the others. But none of the points are special. No point is the center of expansion. And if you are a two-dimensional creature on the surface of a balloon, you will find that your world has no boundaries. You can go on and on. It never ends. But your world is limited. The universe may be like that. It may have no borders, but it is limited. This sounds contradictory, but in high-dimensional space, it makes perfect sense. Our universe may be a three-dimensional sphere, curved, in the fourth dimension of space that we cannot perceive. But here's a more subtle problem. The observable universe and the entire universe are two different things. The observable universe has a clear boundary. That is light in the age of the universe, to be able to reach our farthest distances. This distance is about 46.5 billion light years, because the space itself is expanding. So it's larger than 13.8 billion light years. But beyond the boundaries of the observable universe, there is more universe out there. We will never see it, because the light has not yet had time to reach us. Worse, because the universe is expanding at an accelerated pace. There are areas that are moving away from us at greater speed than light. The light emitted by these areas will never reach the Earth. They are beyond our causality. Here's why. The expansion of the universe does not violate the speed limit of the speed of light. The speed limit of light says information cannot travel faster than light in space. But the space itself can expand at any speed. It's like you're standing on a conveyor belt. The conveyor belt itself is moving, but your speed on the conveyor belt is still limited. Will the universe expand forever? It will still stop, even shrink back. It depends on the geometry and energy composition of the universe. If the universe were closed, it would be like a sphere. Then it will eventually stop expanding. Then the contraction begins. Finally, it comes down to a point. A large squeeze occurs. If the universe is open, like a saddle face, then it will inflate forever. If the universe were flat, then it will keep expanding. But the expansion rate will become slower and slower, close to 0. According to the latest observational data, our universe is almost perfectly flat. Error less than 1%. But here's a catch. The universe is not only expanding, and it is accelerating expansion. This was an amazing discovery in 1998. It directly led to the Nobel Prize in Physics in 2011. This accelerated expansion was completely unexpected, because gravity should slow down expansion. It's like you throw the ball up. The ball slows down due to gravity, but the universe didn't slow down. Instead, it is accelerating. It's as if there is some kind of anti-gravity pushing the universe. Scientists put this mysterious driving force. It's called dark energy. Dark energy accounts for about 68% of the total energy of the universe. But we have absolutely no idea what it is. We only know how effective it is. It allows the space itself to carry a kind of negative pressure, accelerate the expansion of space. The simplest guess is dark energy is vacuum energy. This is the so-called cosmological constant. Einstein wanted to keep the universe static. This item is added to the equation. Later, he discovered that the universe was expanding. Just remove this item. Said it was the biggest mistake of his life. Unexpectedly, this constant came back later. It's just that the symbol is the opposite. Except for dark energy, there is another mystery in the universe. It's called dark matter. Dark matter accounts for 85% of the total matter in the universe. But we don't know what it is either. We only know that it has gravity. It can affect the movement of galaxies and the bending of light. But it does not emit light, does not reflect light, and does not absorb light. It hardly interacts with anything. It seems to have a huge invisible skeleton. It supports the structure of the entire universe. But we can neither see nor touch. Now you understand why. We know less than 1% of the universe. We can see and touch. Ordinary matter that can be understood. It accounts for less than 5% of the total intelligence of the universe. The remaining 95% we don't know what it is at all. We gave them names. It is called dark matter and dark energy. But these names, just saying another way, we don't know. What is even more disturbing is that these 5 questions, in fact, they all point to the same ultimate problem. Our universe. What is it? The starting point in the black hole tells us. General relativity fails under extreme conditions. The speed limit of light tells us. Spacetime has an internal structure. Not everything can happen casually. The paradox of time travel tells us. The law of cause and effect is probably the most basic law of the universe. The Bemi paradox tells us, or we are spatial. Either we are in danger, either we are too young, and the boundary of the universe tells us we may never see the whole picture. And behind all these problems is a deeper confusion. Why is the universe the way it is? Why are physical constants these values? Why is the speed of light 300,000 kilometers per second, and not other numbers? Why is the gravitational constant the current value? If these constants change a little bit, atoms cannot be formed, stars cannot burn, life cannot exist. This is known as fine accommodation problems. The universe looks as if it has been carefully tuned, specifically for life to appear. Some say it's God's work. Some say it's a coincidence. There are also others. A bolder idea was proposed, the multiverse. Maybe our universe is not unique. There may be countless universes. The physical constants of each universe are different. Most of the universe is dead, because their constants do not support life. But there is always some universe. Just the right constant key. Life appeared. And of course we will find out. Be in a pro-life universe. Because if our universe does not support life, we would not exist. Let's ask this question. This is called the principle of man. But there is a problem with the multiverse theory. It cannot be proven or falsified. If other universes, there is no causal connection with us, we will never observe them. So is he a scientific theory? Or is it just a philosophical conjecture? And the multiverse theory raises more questions. If there are countless universes, isn't there an infinite number of you? In a universe, you made a different choice, living a different life. In a universe, dinosaurs did not become extinct in some universe. Hitler won World War II. In a universe, the laws of physics are completely different. We simply cannot imagine the life forms there. It's like opening Pandora's box. Once you acknowledge the multiverse, you have to admit it. All possible universes exist. And if all possible universes exist, so what is real? What is existence? Do these words still make sense? Speaking of which, you might think, modern physics, it has become as mysterious as philosophy. It is. Early 20th century, physics splits into two camps. Study the superscale general theory of relativity and the study of ultra-small-scale quantum mechanics. Both theories are extremely successful. There are countless experimental evidence to support this. But the problem is that they contradict each other. At the beginning of the black hole, at the beginning of the Big Bang, both theories work at the same time. But they gave. The answer is incompatible. Physicists know there must be a deeper theory. It can unify the two. This theory is known as the theory of everything, or the theory of quantum gravity. String theory is currently the hottest candidate. It assumes that the basic building block of the universe is not point-like particles. It is a one-dimensional string. These strings vibrate in high-dimensional space. Different vibration patterns correspond to different particles. This theory is beautiful, mathematically also self-consistent. But there is a fatal problem. He needs 10 or 11-dimensional space, and we can only perceive 4 dimensions. Where does that extra dimension go? The standard answer is that they curl up, so small that we can't observe it. It's like a water pipe. It is one-dimensional from a distance. But if you are an ant crawling on it, you will find that it is actually 2-dimensional. There is a curly dimension. But string theory has a bigger problem. It predicts 10 to the power of 500 different types of universes. Each corresponds to a possible vacuum state. So many possibilities. Why do we live in the present universe? This returns to the principle of man and the problem circle of the multiverse. Quantum gravity is another candidate theory. He argued that spacetime itself is quantized, not continuous. Instead, it is composed of discrete spacetime atoms. Under this theoretical framework, there may have been a shrinking universe before the Big Bang. When it collapses to its limit, a quantum rebound occurred. It has become our current expanding universe. In this case, the universe can be cyclical. Expansion and contraction again and again. Never stop. But no matter which theory, we are all missing key experimental evidence. Build 1. Particle accelerators capable of verifying these theories. Energy needed, probably equivalent to the output of the entire galaxy. We may never make it. This is the dilemma facing modern physics. We have a lot of beautiful theories, lots of clever ideas, but we may never be able to verify them. We may have reached the boundaries of human comprehension. It's like an ant is smart. I can't understand quantum mechanics either. Maybe our brain. This one evolved in the African savanna. 3 pounds of organs. It is not at all to understand the ultimate truth of the universe. And designed. But then again, 100 years ago, who would have thought we would discover black holes and dark matter, dark energy and these things? Who would have thought that time and space are relative? Who would have thought? We can see what the universe looked like 380,000 years after its birth. Human imagination and creativity, breaking through seemingly impossible boundaries again and again.